Hello and welcome to another episode. If you've been following along, we've been going over the LeetCode Top 150 interview questions. Today, we're going to be looking at remove duplicates from sorted array number 1, question number 26. So without further ado, let's get right into it. So the remove duplicates from sorted array problem is given an easy difficulty. However, it is a little bit more difficult than you might think. So we can see that the question states, given an integer array nums sorted in non-decreasing order, remember, non-decreasing means that it's ascending, but there could be duplicates. We're supposed to remove the duplicates in place, similar to the last problem that we worked on. In place just means that we're not going to create a new array, we're going to use the one that already exists. And we're going to do so in such a way that each unique element appears only once. The relative order of the elements should be kept the same, and then return the number of unique elements in nums. Consider the number of unique elements of nums to be k. To get accepted, you need to do the following things. Change the array nums such as the first k elements of nums contains the unique elements in the order they were present in nums initially. The remaining elements of nums are not important, as well as the size of nums, and then return k at the end. Okay, so if you haven't watched my last video, first of all, go back and watch that because it's almost an identical problem set. But anyways, we're going to get right into this. Let's look at this first example. Alright, so looking at the first example here, we're giving the integer array nums, and we're given three values, 1, 1, and 2. Simply put, we want to return the 1 and the 2, getting rid of the duplicate 1. This seems very simple, and if we follow the same methodology that we used in the last video, we know that we can use pointers. So we'll use a pointer, and we'll start at the first location, or the second, considering the first can never be a duplicate, and we'll compare it to the subsequent values after it. If the first value does not equal the second value, then we will place the second value in this location, and we'll continue going on using the pointers. It might sound a little bit confusing, but we'll show you in this example here as we start to work through this problem. Okay, so to start with, I'm going to create a pointer, and I'm going to call it k, considering k is the value that we're supposed to return in the end. So now that I have k, I'm going to give it a value of 1, because I'm going to say that the first element is always unique. So now that I have that k equals 1, I can go ahead and create the for loop that will go through the rest of the elements. We will say we'll say I in the range of the length of nums. So we're going to pull all of the elements from nums, and we're going to go through each of them one time. But since we're going to actually start at k equals 1, meaning we're going to skip the first element, we actually need to start our range at the value of 1. So it'll go through 1. It will go from 1 through the end of this range. After this, we can see if our nums I value does not equal nums I minus 1. And if that is correct, then we can assign nums k to be equal to nums I. After that, we will want to make sure that we increase k by 1 for each occurrence that we have. And then in the end, we will return k. So let's go ahead and run this. Oops, I forgot my if again in the if statement. Let me go ahead and run that again. And now we can see that this test case is accepted. And if we go to submit, we can see that our problem beats 61%. It's a very fast runtime. And speaking of runtime, let's actually go through and say what the runtime is for this problem. Okay, so for our time and space complexity, our time complexity is equal to big O of n. So big O of n is saying that we're going to go through each element once. That makes sense because we're going through every element except for the first in this array one time. Does not matter how many elements are in this array. It will go through it one time every single time we run this function. And then our space notation, using in place, it's always constant space. So we know that this will be big O of 1. Okay, so that is all I have for today. If you have any questions, feel free to leave them down below in the comments, or if there's any other videos you would like to see in the future, leave that there as well. I'm so grateful for everybody supporting this channel and for watching my videos, and I want to make this content something that you enjoy, so let me know anything that I can do to make it better for you. Again, if you did not watch the remove element video from last week, feel free to check it out. It has a lot of the similar functionality that this question has as well. I'll leave a link to it right here. But that's all I had for today. So thank you again so much for watching, and I'll see you in the next one.